We're covering Trig Unit 4, Day 2, period changes to sine and cosine graphs. I will redefine what period is. We did it on the first or the pre-day worksheet, and then we're going to graph sine and cosine functions with different periods. We're adding on, so we're also going to be looking at amplitude and vertical shifts as well. All right, so on the pre-day worksheet, you had to find the period of a parent function, or just the basic sine x, and that's how long does it take, how many radians does it take before it starts repeating itself. And we notice that once we get here, start repeating, and that happens to be 2 pi radians. Same with cosine. So if we start here, when we get to here, we start repeating, so the period is 2 pi. So we're going to add on to this equation we have for our sine and cosine. We've had A and D, we're adding B today, and B is going to be the number in front of the x. So it's going to be a parameter that's passed into the sine function itself. So A is amplitude, B is your horizontal stretch, and I'm going to show you how you use that. It basically either stretches it out or shrinks it, and so I call it the horizontal stretch. It also then defines your period. And then D is the vertical shift. So for y equals sine bx, the graph is stretched or shrunk by a factor of 1 over b. So just like all our other functions where we looked at transformations, when we're talking about the horizontal stretch factor, the stretch is actually 1 over the number that you see in your equation, and it's true of sine and cosine as well. So if we have a b equal to 2, we're actually going to have a stretch of 1/2, or you could say it's being shrunk by 1/2. Absolute value, so notice that. So if I have a negative 2x, this horizontal stretch is still going to be 1/2. What does the negative do? Well, it causes a flip over the y-axis, and I have that down later. But also, so I told you that b defines your period. How does it define the period? Well, the period is going to be 2 pi over b. So period equals 2 pi over b. So if you have a b is 2, your new period is going to be 2 pi over 2, or pi. And that makes sense to you. It's shrunk by 1/2. 1/2 of 2 pi is going to be pi. So if b is less than 0, so that basically means if you have a negative in front of your b, the graph is reflected over the y-axis. And if you look at this, what happens when we reflect either of these graphs over the y-axis? Well, for the cosine, it's hard to tell. It looks like for sine, what you would get is something that looks like this, so you could tell. But for cosine, a reflection over the y-axis is basically not, unless you have a phase shift, it's hard to see. All right, so let's look at the first example. Not to graph, we're going to graph y equals 2 sine 3x. So again, you want to start by identifying your a, b, and d. Our a is 2, meaning we have an amplitude of 2, and a vertical stretch of 2. I think I'm using the uncorrected. I actually corrected this, but this is the older version. Anyway, so we have an amplitude and a vertical stretch of 2. There's no vertical shift because we have no d. And b is 3. That means we have a horizontal stretch of 1/3. So I'm going to show you how to graph this by showing you how you're going to convert your 9 hash marks. So we know that we're going to take our amplitude and multiply our y value by that. We're going to modify our x coordinates today by multiplying them by 1 over b. So in this case, we're going to multiply them by 1/3, which is what I have done there. So if we look at our new hash marks, our first one, negative 2 pi 0, we're going to multiply negative 2 pi by 1/3. And remember, it's negative 2 pi over 1 times 1/3. Multiply across your top and across your bottom, and that's where we get negative 2 pi over 3. 2 times 0 is 0. Negative 3 pi over 2 times 1/3. The easiest thing to do is cross out your 3's on top and bottom, and you're going to get negative pi over 2. 2 times 1 is 2. This is going to be negative pi over 3. This is going to be negative pi over 6. Multiply your top and bottom. 0. 0 times anything is 0. This becomes positive pi over 6. This becomes positive pi over 3, positive pi over 2, and then 2 pi over 3. And if you look, we still have 4 hash marks that are negative and 4 that are positive. So when we graph it, we're still going to put this is the middle, and we're going to have 4 evenly spaced, because even though we have a horizontal stretch, these are still evenly spaced. They're just not spaced out pi over 2 radians. In fact, you can tell what's the difference between this and this. Well, this is pi over 6 less than this, so you're adding pi over 6 each time, and that's basically what this interval in between those units are. So let's go ahead and graph it. Here's our, oops, let me pull that back up. So here's our new hash marks. As I said, we have 4 negatives still, and when we get into phase shift, that's not going to be the case, and 4 positive. So I'm going to make 1, 2, 3, 4, 1, 2, 3, 4, and our amplitude goes from -2 to +2. So 1, 2, 1, 2, and then we just graph those. So this is going to be -2 pi over 3, negative pi over 2, negative pi over 3, negative pi over 6. Make sure you label your scales. Whoops, that's not right. Going the wrong way there. So -2, -1, 1, 2, and then this becomes pi over 6, pi over 3, pi over 2, 2 pi over 3. So this has a point. Let me make it a different color. Green here, negative pi over 2, -2 is here, 0. Something's not right here. Oh, that's a +2. So pi over 2 is a +2. Then we have a 0. Then we have a -2. Then we have a 0. Then we have a +2. 0, -2, 0. So connect your dots, and you get your new sine curve. And now we're going to find all our key characteristics with a few extras this time. So our y-intercept, fortunately, we already have it. When x is 0, 0, 0. We have our x-intercepts as well. These are all the points where y is 0. Our mins are when the y value is -2, and our max is when it's +2. Vertical stretch of 2, amplitude of 2, no vertical shift, no flips. We're going to also identify our period. So as I said, our new period is going to be 2 pi divided by our b, so it's 2 pi over 3, and that gives us a horizontal stretch of 1/3. All right, graph 2 cosine of 1/2 x minus 1. So we have an amplitude of 2. This gives a vertical stretch of 2. We have a vertical shift down 1, and we have a b is equal to 2, which means actually, oh, sorry, b is 1/2, which means our stretch is going to be 1 over 1/2. So if you divide by a fraction, you can multiply by the reciprocal. So 1 is just going to be 1 over 1 times the reciprocal of 1/2. That gives us a vertical stretch of 2. So we're going to multiply our x coordinates by 1 over b, which is 2. Multiply our y's by our amplitude, and then subtract our 1, which is our vertical shift. So you can see it's a lot easier now to deal with your new x coordinates because they're multiplied by a whole number. -4 pi, and this becomes 2 minus 1 or 1. This becomes, well, you can cancel your 2's out top and bottom. You're going to get -3 pi and -1. negative 2 pi. These cancel out and you get negative pi, 0, and again pi, 2 pi, 3 pi, 4 pi. So each set of coordinates is incremented by pi. And now we're going to graph. I'm trying to get this. So here's our hash marks. Again, we haven't changed the number before and after. So we've got 4 negative and 4 positive. So I'm going to make 4 evenly spaced x marks or x coordinates 1, 2, 3, 4, 1, 2, 3, 4. And min is negative 3. Looks like max is, oh, we've lost our 4 pi over 1 here. Is that right? So we're going to graph. So we have a 1, 2, 3, 4. And let me change the color again. So negative 4 pi 1. Whoops. Also want to label your graphs. 3 pi, negative 2 pi, negative pi, pi, 2 pi, 3 pi, 4 pi, and then 1, 2, 3, negative 1, negative 2, negative 3, negative 4. So negative 4, 1, negative 3 pi, negative 1, negative 2 pi, negative 3, negative pi, negative 1, 0, 1, pi, negative 1, negative 3, negative 1, 1. So you can see we're going to get our cosine curve. Our y-int has been identified. Our x-int, we don't have any in our hash marks, so we're going to use trace and get approximately those for our x-intercepts. Minimums are when we have y being negative 3. Max is when y is 1. Our vertical stretch should be 2. An amplitude. Vertical shift down 1. No flips. A period is going to be, again, our period is equal to 2 pi over b, which is going to end up being 4 pi, which you could probably tell from looking at the graph anyway. And then we have a horizontal stretch of 2. Okay, so you should try and find your new hash marks for this function. Notice we have a negative in front of the b, so instead of multiplying by 1 over b, you're going to multiply by a negative 1 over b. That's the only difference from the examples I gave you. So I think that is the last slide. Homework is your worksheet, and there is a new web activity up. Bring questions to class.